Okay. Graphing inequalities follow the same steps that you do for graphing equalities, equations. Okay? You just got to make sure that you take a look at where the shading goes. So if I were to go and take a look at this one, I'm going to graph the line. I graph the line. It's shaded below it. But whenever you do this, always put it in the form of a function so that you know what y is being compared to. So when I'm looking at something like this, that means y is going to be less than or equal to negative 3x plus 6. Make sure you put it in that form. Otherwise, it's going to be hard to know where do I shade. Do I shade above or below? Let's see. Steps for graphing inequalities. Just make sure you follow the darn things through. Okay. Always go through and graph the equation that you got as if it does not have an inequality. That's what you need to do to find where your boundary is going to be. Okay. Then after that, then you got to do the regions. And if you want to test to make sure that you've got it correct, pick a point. See if it works. Does it fit the inequality on it? So for example, here they got a circle. X squared plus y squared is less than 4. Graphed out the circle, which we know is centered at 0, has a radius of what? 2. So we just draw ourselves a circle. Now I want values that are less than that. So what does less than on a circle look like? There's only two places. There's inside and there's outside, right? If I pick numbers on the outside, I would expect it to be what? Bigger? I pick numbers on the inside, I would expect things to be smaller. The thing is, if I were to pick the point, say 1, 1. 1 squared plus 1 squared is 2. Is 2 less than or equal to 4? Well, yeah. So that means you'd end up with a point on the inside here, 1, 1. So I've picked a test point and I says, hey, it worked. It was where I expected it to be, so therefore this has got to be the correct region that is shaded. That's all it is. So when we graph something like this, we're going to graph those lines. Again, make sure that you put them into the form y less than or greater than or whatever, or just simply graph them as y equals. Where you get the overlap, that is where the solutions are going to be. Now I'll caution you because sometimes you've got less than and greater than, not less than or equal to or greater than or equal to. Don't pick the intersection point and don't pick number or points on the line unless you actually have to do that for the problem that they're giving you. Pick it inside here someplace, inside the shaded region. The double shaded region, where it overlaps. Because that is where you are going to get the answers or the solutions to this particular problem. Okay. Now, there are possibilities here. You got overlap here. That's all fine and dandy because you got your answers sitting right in here. If you take a look here on example 7, there's a gap. No solutions. Okay. Here, all the solutions are going to be less than down here. These aren't going to be part of the solution. The line here can be part of the solution because we got equality here. Remember, it's got to be where the overlap is. So if the equation down here would have been, say, at a less than, didn't have the equal to, this would be a dotted line and it would not be part of the overlap because a dotted line isn't part of what the equation is to begin with. So that sort of kind of makes sense. All we're going to be looking at here is just graphing the lines and seeing where they overlap, graphing the curves, seeing where they overlap. It does not matter how many of them you have or what kind of equations that you have. If you get down here, graphing a system of 4 linear equations. Okay? X has to be greater than 0. Y has to be greater than or equal to 0. So it can't be anywhere in the third or second, third, or fourth quadrant. It can only be in the first quadrant. Has to be where y is greater than or equal to negative x plus 3. Y has to be greater than or equal to. So that means these are being shaded above, those are being shaded above. So it's going to be all of this material or this area up here. That's where it's at. It's just simply taking what you have gotten and moving it up and utilizing everything that you've got. Now the thing is, this actually comes out to be something called linear programming. They actually did this back, or they've been doing it for years. They refined the process during World War II. And this idea of linear programming using a simplex algorithm was actually something that was classified as top secret. The reason that they were doing this was because it was an efficiency model for trying to get material over to the war zone. Oh, that's great. So it was considered a top secret thing that nobody else should know. And it wasn't declassified until the 60s. It was that important because it saved that much money and made things much more efficient. So basically what it boils down to is when you get something like this, all your solutions are sitting in here. The simplex algorithm took it one step further and said that you are going to maximize or minimize at the intersection points or the vertices of whatever the shaded region is. So when you get down to a problem like this, when it talks about financial planning, set up the equations, graph the equations, shade in the overlapping region. Then pick the points, the intersection points. Those are going to be either your maximum or minimum solution for the problem. Okay. And the best thing is to do is just dig in, do these. When you got questions, ask, we'll go over it. Because you guys know how to graph equations. You guys know how to shade inequalities. Okay. It's just the application of what is that answer then. So there you go, have at it.